This is one question from the chapter Similar Triangles. You can see a figure is given here, and that's triangle is named as ABD here. And it's further mentioned that this angle A is 90 degrees. So the angle A is 90 degrees. We are also given that this line BAC is perpendicular to this line BD. Right. So these are the information we have. And what we need to prove here is AB square. This is AB square is equal to BC into BD. So this is AB and BC into BD. That is, this is BC and BD. So what you can conclude that we need relation between these sides. And obviously, once we prove the triangle similar, we can write these sides proportional. That should give us the result. But then we can also conclude from here that since we need to involve AB, BC, and BD, the triangles to be proved similar has to be one this, and the other triangle, this one. So this is what we need to prove here. What you can see here that if I take the triangle here, that is the bigger triangle, which is ABC here, we know one angle is 90 degrees here. That means the sum of the other two angles, let's say if I talk about, or before that, I must name these angles as say 1 and this as 2. Now, since one angle is 90 degrees, therefore the sum of the remaining two angles, that is angle B plus angle D, should be 90 degrees. That's from angle sum property. And if I mark this equation 1. Now I'm going to consider the other triangle, which we have already decided that we need to prove this triangle. From here, what we can conclude that in triangle ABC, we have angle C, that is angle ACB is 90 degrees. So from here again, we conclude that the sum of the other two angles is what? Angle B plus angle 1 is equal to 90 degrees. And the reason remains same, that is angle sum property. Now from these two equations, what you can see that we have both equal to 90 degrees. The sum of both is equal to 90 degrees. So we can write from here, we can conclude that angle B plus angle D should be equal to angle B plus angle 1 here. So D is equal to 1. So angle 1 here is equal to angle D. Similarly, we can prove angle 2 is equal to angle B. But then we don't have to write this. We can write similarly. Similarly, we need to write down. Similarly, angle B is equal to angle 2. So once we have obtained these, now we can prove the two triangles similar. Now for that, let's say if I make some space for this. The two triangles which we need to prove similar, we have already decided that we are going to consider one triangle this and the other the biggest triangle here. So we'll write in triangle A, B, C, and the other triangle, and that is ABC, and the other triangle is a DBA. Now what you can see here that in these two triangles, so we have already proved one angle 1 is ABC, that 1 belongs to triangle ABC is equal to angle D. Further, we can see that angle B is common here. So angle B is equal to angle B. Right. So one more time. So we have proved one angle this of ABC is equal to angle D, and we have angle B as common. So we can write the triangles as similar. But it is important to write them in the correct correspondence. So A, that is angle 1 of triangle ABC, is equal to D. So that's a reason A corresponds to D, while B is common here, and C, which is 90 in this case, A is 90 in the other triangle. Now we can use the correspondence, that is AB here. Correspondence, by that I mean to say that I can adjust it here. So AB, that is AB over BD is equal to BC over BA or AB, the same. Now, if I do cross multiplication between these two, what we'll get here, that is AB into AB, which is AB square, is equal to BC into BD. can see that we have proved the first part here. Now, the other parts can be done in the same way, like mark it as AD square is equal to BC into BD. So therefore, we need to consider a triangle where AD is common. So the one triangle is this, and the other triangle has to be the biggest one, that is this one. Now here in these two triangles, again, you can see, let me first consider that a triangle, we need to mention it. That is, if I take ACD first, and that is BAD. In these two triangles, the shaded one, you can see that we have angle D as common. That is, angle D is equal to angle D common. These are the common angle. And further, which is angle 2 of this triangle, that is ACD, is equal to angle B, and that is proved above, right? This is, we have already proved. So from here, we can say again the triangles being similar, that the triangles has to be ACD if I write. Now, what is A? A for A is nothing but angle 2 here that corresponds to, right? A for this triangle, ACD, which is angle 2, and 2 corresponds to B. That's why I should write B here. C, I can see in this triangle, C is 90. In this triangle, C is 90, and C is angle A is 90 for the other triangle. And as we decided that D is common, so let it be here. To start with AD. So here AD corresponds to BD, and we need AD again. So we'll take CD, the last two letters CD corresponds to AD. Now, if I do cross multiplication, we'll get AD square is equal to BD into CD. So this is how the second part is proved. Now, coming to the third part, we need AC square here. So the AC, therefore, we'll be proving the triangle in which AC is common. So one is this, and the other triangle is this. So we'll prove these two triangles similar to get the result for the final part. So the triangles this time should be considered will be the triangle ABC, and the other triangle, that is here ABC, that is triangle DCA. Now look into this triangle. First of all, we have angle 1. Angle 1 of this triangle is equal to angle 1 of triangle ABC is equal to angle D, and similarly, angle B of this triangle is equal to angle 2. So here too, we prove the two triangles similar. So once we prove the two triangles similar, we can write their correspondence. Similar, that is, say, if I take ABC in any order, well, A of this, which is angle 1 corresponds to angle D. So it has to be D here first, D. And B, which is for the other triangle, angle B corresponds to A, and C is 90 in each case. So we should first take this proportionality, and then we take the triangle similar in this correspondence, and then write their sides being proportional. Now, if I take AC, that is first and last, here AC over DC, or say CD, is equal to, we need AC again, so I'll take BC over AC. Now, if I do cross multiplication, we'll get AC square is equal to BC dot CD. So this is how the three parts can be done.